Okay, let's have a chat about guidelines. So the core guidelines, yes, they are the most well-known. We touch on them a bit, but this is mostly about guidelines in general or guidelines in projects. Hi, I'm Arne. I work at Züge for a bit over 9 years now, mostly in embedded projects. I've done some non-C++ stuff as well. But in general, in C++, I work for a bit over 20 years now, and besides working on those projects, I'm also a trainer for C++ and clean code, maintainable code testing, and the like. So the context of this talk is basically experience from a bit over, around 12 projects over the last 9 years, a bit from the time before with different employers. Very different industries, very different environments. At Züge, sometimes we have teams where all of the team is developers from our side, and we just have a product owner from the other side. Sometimes we have mixed teams of developers with developers from the customer side. The common baseline that I see in basically every project ever is that there's some kind of style guide document. Sometimes they're provided by customers. Sometimes the customers don't provide a style guide document. Then usually the team comes up with a style guide document. More or less closely followed. So sometimes people, yes, there is a style guide document. I don't know where it is, and I don't know what's in there, but we do have one. In recent years, quite often the style guide documents are inspired by C++ core guidelines. Sometimes core guidelines are copied. Sometimes people just say, okay, we follow these guidelines. Sometimes they also just say, yeah, we follow the core guidelines, not knowing what's in there. I've also heard in earlier talks, we follow the Google guidelines, not knowing what's in there and what the consequences are. So, as a bit of a warm-up, how this talk is going, this is a proverb: Jack of all trades, master of none. Who has heard this one? Great, a few. What does it mean? The common meaning that we see is somebody who can do everything a bit, but nothing really well. Is that the original meaning of this proverb? Hint, it's not. The original proverb is Jack of all trades, master of none, but oftentimes better than a master of one. So the master of one is usually, or quite often we find someone who is a perfect expert in something, but only knows that one thing, and everything else is a bit I don't know it, I don't touch it. But in projects, we need some of these experts, but we also need generalists, right? Especially if you have a very small team, like 2-3 people or something like that. If everyone is a C++ expert, well, who will build your stuff? Who will maintain your CI? Who will do the project management? There's lots of things to do besides programming C++ usually, right? So we need generalists. Or I think one of the best compliments I've heard in the past is a Swiss Army knife developer. There is something new. We have to do something with maybe Python, or we have to do some documentation and come up with a way to actually generate beautiful PDF documents from our Markdown and stuff like that. You need a Swiss Army knife developer who just sits down and figures it out how to do it, and you need generalists. So much for the warm-up. So we will go through a couple of guidelines in this forum, guidelines how we found them in projects. I try to figure out where those guidelines actually come from, so find some sources. What the impact of the guidelines, how we find them in projects is for those projects, for the code, and what we can learn from them. And then in the end, I will have some guidelines for project guidelines. So let's talk about one guideline found in the wild. Define or delete all copy, move, and destructor functions. Who has seen this one? Where does it come from? Rule of 5. Is that the rule of 5? Let's have a look. C21 Core Guidelines. If you define or delete any copy, move, or destructor function, define and delete them all. There's a difference. If you define one, then do the others. More importantly, there's C20. If you can avoid defining default operations, then do. This is the rule of 0. So the first rule is the rule of 0. And if you actually have to define one because you do some memory management, some resource allocation, stuff like that, then please define the other ones as well. Why is it? Well, if you have to allocate memory, then you probably have to deallocate it in a destructor. You have to deal with movement, so you move the allocation to the new object or copy. Either you have to delete the copy or you have to actually do another allocation in the copy constructor, copy assignment, so you don't get double free and stuff like that, right? That's the reason for the rule of 5, to do your resource management right, but also to communicate. This can be defaulted, this can be defaulted to communicate to people who read your code. You haven't forgotten the copy or the move. You actually have considered it, and the default is the correct operation here. So this one basically tells you always define them. And if they are all correct, then equals default, equals default, equals default, equals default. That's not the meaning of the actual core guideline, right? So what is the impact of having this in your guideline document and people following it? It means people write needless boilerplates. I've seen code bases where people just write, okay, I have a new class, my default constructor equals default, my copy constructor equals default, my move constructor equals default, my destructor equals default, copy assignment, move assignment. Okay, where was I? Okay, this is now my class. And they write this in every single class. And then they allocate memory. And they defaulted their copy assignment, and then you have the double free. Because if you have to do this always, 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 it just gets mindless boilerplate, people stop thinking about it, and it just does what the actual rule of 5 wants to avoid, that you don't think about what you are doing here with resources, resource acquisition. Or they go the other way around, well, I'm not sure whether I can actually copy this or move this, I just delete everything. Good luck using one of those types in std optional, std variant, where you have to move things internally, or put them in a vector where you have to move at least or copy stuff internally. If everything is deleted, then everything is very static and you can't do much with it. You end up with a code base where I want to have this here, I want to put this over there. I just put it on the heap. And you have lots of memory management, lots of needless memory allocations, and you are getting away from value-based computations, and it gets more complex than it needs to be. About this rule of 5, I said I was talking about guidelines, right? Not about rules. Obligatory movie quote here. The code of the pirates is more what you'd call guidelines than actual rules. So guidelines you don't have to follow closely. Rules you do. So when we have a guideline document, why do the developers then say we do have to do this, we have to do this? Well, turns out that developers love rules. Because they're strict, they're clear, we can turn our brain off and focus on the actual stuff we want to do, solving problems, right? We are used to having rules because our compiler says this is correct, this is wrong code, this is correct code, so it's 1 and 0. It's nothing in between. It's nothing like, yeah, you might be thinking about, but you should maybe. It's just correct or wrong. Rules are great. They can be checked automatically. Compilers, static code analysis, stuff like that, right? So why guidelines? Guidelines are less strict. There are exceptions. So if you look at the core guideline documents, they write down, prefer, consider this, but there are exceptions. In those and other cases, maybe you don't need to follow this guideline. And it's okay to not follow this guideline if you have thought it through, and if there are reasons not to follow them. So we have the freedom to not follow them, but we also have the responsibility to think about whether we want to follow them, whether we don't need to follow them, and why we don't need to follow them. And so we should not interpret guidelines as rules, except when they are rules, like rule of 0, rule of 5. Maybe they are actual rules because the name says it, but also because they make sense in pretty much every occasion. And it's more consistent. Like if you don't follow the rule of 5 and you just have like a destructor and a copy constructor defined, then someone will go ahead and say, did they forget the move or what's going on here? So it creates confusion, right? And just following them and writing them, if you actually have to do it, then write them all down and it's usually fine. So please don't define and delete and so on everything for every class. Think about if you have to, RAII classes and similar things, then do it, but please try to follow the rule of 0 as a first approach, and then if you actually have to write one of those, then follow the rule of 5. One side note about tooling. I mentioned tooling for rules, and the guidelines say there are rules because the wording in the core guidelines is a bit. The whole document is named core guidelines, and they say this is rule C21, this is rule C20. Those are rules, but they're guidelines. There is automated tooling for some of the guidelines, especially for the core guidelines. There in Clang-Tady, there is a set of guideline checks. For example, CPP core guideline special member functions does exactly this. It will not complain if you don't define any of the 5. It will complain if you define 1 or 2 or 3 or 4, but not all 5 of them. So you will get a warning. Maybe you forgot some or you want to do all the 5. This rule can be configured in the Clang-Tady. So for example, it may be okay for interfaces to only define a defaulted virtual destructor and not touch everything else. That can be okay for interface classes, but you have these options to check them. But on the side, when we have our Clang-Tady file and Clang-Tady gives us warnings, do we really have to write these things down in a guideline document? Because Clang-Tady will point us to the core guidelines, right? Next guideline found in the wild. Don't use exceptions. Excuse me? Where did that come from? And this one is very popular. Any idea where that comes from? Yes? Google, yes. Google Style Guide says something like that, not that exactly. Google Style Guide says, we do not use exceptions at Google. Because for existing code, the introduction of exceptions has implications on all dependent code. Most existing C++ code at Google is not prepared to deal with exceptions. Our advice against using exceptions is not predicated on philosophical or moral grounds, but practical ones. Things would probably be different if we had to do it all over again from scratch. So my interpretation, we would like to use exceptions, but we have such a big and old code base, we just can't. it's not practical to try. I've given this talk 2 times before, and after the second time, came one person and said, I actually have worked at Google, and we have this in the guidelines, but we have projects at Google that use exceptions because we are not like a base dependency of everyone else, and we can use exceptions, so we do use exceptions. But the general guideline for the big whole code base of Google is we do not use exceptions because it's not possible. It's not, don't use exceptions. So what's the impact of not using exceptions? Excuse me. So first of all, exceptions are part of the language for a reason, because they facilitate error handling in a specific way. They have to be handled. You can't just ignore them. If you do, well, then your program just terminates. They can be handled, or they are handled where they can be handled, and you don't have to check, okay, did this give me an error? Then I have to pass the error along. In the next function, did this give an error? So exceptions can bubble up to the point where you can actually handle them, right? And not using exceptions has impact, and you have to think about your return channel. If you just return an error code, then what your function actually wants to return has to be done via auth parameters, or you have to bundle stuff. You can ignore return values and all the kinds of things. And writing the code and having error handling in every layer of your functions is a bit tedious, and testing the code, testing that every function does error handling well and propagates error and stuff like that is also tedious. So having exceptions can make your code much more readable. There are cases where you just can't use exceptions. If you work on a project where you work on a tiny chip that only has 20K of memory, then having an exception stack of 40K of memory or something like that is just impossible. You can't use exceptions. But don't use exceptions as a style guide has an impact. It's not good. So the context matters for the guidelines. If you get guidelines from somewhere else, see whether you are in the same context. There are many guidelines that are not universal, that apply to a specific scope. And there are many guidelines that don't apply to maybe to your project, to your team, that are not portable between different teams and so on. So check whether a guideline applies to you before you adopt it. So please don't use exceptions unless you're Google, of course, or specific parts of Google. Please do use exceptions consistently. So if you can't, then it's okay. Also, please don't mix exceptions and std expect and maybe plain C error codes in one code base. That's really hard to reason with, right? But unless you have good reasons, I really recommend using exceptions. Good reasons can be plenty, but the default should be this and not using exceptions. Another guideline found in the wild. Every function shall have a single return statement. SE. Yes! Where did that one come from? A function shall have a single point of exit at the end of the function. MISR C15, MISR CPP 665. This is about functional safety. Very often seen in automotive and similar contexts. Reasons given in those guidelines are readability and avoid leaks. There are, to both things, are some counter-arguments. So readability, if you have guard clauses, like early returns, if I get a past null pointer, I can just return because I know I can't work with this data. If my data is working in any other case, just return and be done with this. And then you have basically a part of the function that does the actual work, right? These are a pretty common pattern, and they actually improve readability. Resources, well, this is probably from the C part of the guideline, or the C heritage of the guideline. If you use RAII, you can have early returns, and you don't have to deal with resources manually at the end of your function. So this one is out of the way as well. And if your readability is low because you have like some return in the middle of your function, and that is a problem, then it's usually because you have a very long function that does very different things at deep levels of detail, and then you have other problems. Then having just one return at the end of the function won't improve the readability of that function. And context matters. Yes, sometimes you have to follow external standards, but that doesn't mean that if I do a toy project, I have to follow the MISRA guidelines, right? So if you don't have to follow those standards, then really think about whether you want to adopt them, because they are usually a bit more restrictive. Also, you don't want to repeat those guidelines in your standards document, those standards in your guidelines document, because you usually have like, okay, we have to follow MISRA, and this is a link to the actual MISRA standard that we have to follow, and those are huge documents. You don't want to copy-paste them into your guideline document, right? And picking one or two of those into your guideline document also doesn't make much sense. As before, especially MISRA guidelines are often supported by automated tools. So same as before, if your automated tool tells you you have multiple returns inside your function, please make it a single return, then you don't need to have it in your guideline document either. Actually, in MISRA 23, for C, this is no longer a guideline, this is a minor code smell. And I was told this morning that in MISRA C++ 23, this is completely out. Yay. How about this letter part, SESE? What does that mean? So if you dig deeper, where this MISRA guideline originates in, SESE means single entry, single exit. Single entry, what? Excuse me? So where this comes from is don't jump or go to or entry into alternative entry points in a function. This is assembler, Fortran, all the good stuff from the 60s, right? Single exit doesn't mean don't return from specific places in your function to your call site. It's don't return to different places outside your function. So again, jumps and return to stuff and things like that. Nothing we can really do in C++ without trying very hard and breaking the code and introducing undefined behavior. So there are notes on structured programming by Edgar Dijkstra from 1970. So this is, at least as far as my research goes, this can all be tracked back to. I don't think he knew modern C++. So what's the impact of this kind of guideline rule? So I have a function, find the proverb origin. I have to define a return value because I have, over the course of the function, I have to assign stuff to it. I have to write a value, am I still okay? If my proverb is empty, then okay, do some error logging. I say is okay is false, and I know I'm done right now, but I can't return. I have to go on. And then I say if it's okay, then I do something, and if it's okay, then I do something more. The alternative to is okay is I say if not proverb is empty. If I have a connection to my database, if I can find the proverb in the database, and so on. And I get like nested ifs out of the door, and at the end I have to like go back. What was my context again? Okay, return whatever I got here. And maybe I didn't even assign anything else to my return value because I completely lost track, right? So forcing single exit reduces code quality. I have to have this return value in most cases. I either have to do this is okay pattern or have the deep indentation. And oops, I can't use exceptions. Because even calling a function that might throw an exception is an implicit early return-ish of my function. If I have to do this kind of like reason about, okay, this is what my function actually does, and I have to go through the whole function, and I have to do cleanup manually at the end of the function, I can't use exceptions at all. So this is a hidden requirement of this rule to not use exceptions in the code that I'm calling here. And also, obviously, not throwing explicitly. So please know where your guidelines come from. Some are very, very old. I've asked at my last employer, why don't we do like early returns? Well, because someone who already left the company has said so. And I mean, you can try to call them and they will tell them, well, I've read a paper once in 1970, but that includes guidelines that are not that old, but maybe written for C++ 98 and stuff like that. Really think about whether the guideline still applies for your code base and for the kind of way of how you write your code. So please don't cite rules that are outdated, that don't apply anymore. And please use early returns, guard clauses. Please use RII to handle your resource responsibility management. So the original RAI means resource acquisition is initialization, right? My favorite reinterpretation is responsibility acquisition is initialization. So if I go ahead and change my cursor to a spinning wheel because I'm doing some calculations, then undoing that is not really a resource, it's a responsibility. And I can do this with RAI as well. Of course, unless you have regulations that say we follow MISRA C from back in the day, then probably you're out of luck. And you will have to follow this because someone will check this, and it's bad to not follow your requirements if it's like regulatory and stuff like that. Next guideline. Don't use references as members. Sounds familiar? Mm-hmm. Core Guidelines, C12. Don't make data members const or references in a copyable or movable type. In a copyable or movable type. They make subtype difficult to use by making them at least partly uncopyable because, well, you can't do a copy assignment or move assignment to something, to an existing reference, right? If you want to refer to something else, then a reference doesn't allow that. You want to use a pointer. If you want to assign to something where a member variable is const, well, you can't assign that member variable because it's const. The note in the guideline is to use pointers instead, especially GSL not null to basically mark this pointer cannot be null. Then your static analysis can say, well, you initialize it with a null pointer, you can't do that. But this is a guideline. So it makes it difficult to use by making them at least partly uncopyable. If making them uncopyable is not a problem because you don't need the copyability, that means we can interpret this as in a type that is designed to be copyable and movable. So in value types, you don't want these kind of members. Anything else? Why not? For example, I have a quote randomizer service. that somehow needs a code repository. And the naive, trivial implementation would be, I have a reference to my repository, I have my constructor where I get dependency injection, and I just store the reference to the external code repository. This type is copyable, so the vector is copyable, the random engine is copyable, except for the repository reference. Do I need to copy this service? Probably not. Do I need to move it? Probably not. I can assign it maybe if I have to move it into a variant or stuff like that. Move construct it. So I can copy construct, move construct it, I cannot assign it. And I probably don't need assignment. I don't want to assign something else to a service, right? So this is something that I usually instantiate at the start-ish of my program, and then it lives there until it's no longer used and everything is cleared. So this goes for all the buzzwords from domain-driven design, application services, factory stuffs, repositories, all this kind of things. We usually instantiate one or two of them, and then they live there for the duration of our program, and then they go away. We don't want to assign to them. Do we actually want to write copy assignment equals delete, move assignment equals delete, and stuff like that? Do we have to? Probably not. So there is no need to have them copyable, movable, so we can give them reference members, const members, if we want to. So the reason for guidelines matters. So guideline in the core guideline document usually is not a single sentence. It's like a title, a bit more elaboration what the title actually means, then 2, 3, 4, 5 paragraphs of rationale why this is important and where this is important, whether it does apply, exceptions, and so on, right? And we have to take those into account, not just the title. And if we just blindly follow them, then well, GSL, not null T star, is a bit more verbose and less readable than just T star, right? Or Tref. Also, don't ignore the rule of zero. As I just said, don't just define, okay, I'm actually not copy assignable and this guideline is okay. Then you don't follow the rule of zero anymore. So there are guidelines that basically kind of contradict each other. So please don't be dogmatic. Please don't say, okay, the guideline says this, I have to do this everywhere. Think about where this applies. And use references to build relations in an immutable object graph, because you have like this graph of dependencies, you have your service that depends on your repositories and stuff like that, and you usually build these and they are static. You don't need to move or add much to this. A guideline in the wild. Const goes on the left of the type, West Const. Core guidelines. NL26, use conventional const notation. It does not say use West Const, right? Well, it kind of does. It has an example, piece of example code where they actually use West Const. But you can just remove the example code and replace it with something else, and suddenly the guideline says use East Const. More importantly, the reason is conventional notation is more familiar to more programmers, so whatever your convention is, stick to your convention. That's the more important meaning of this one. Note, this is a recommendation for when you have no constraints or better ideas. So when you have better ideas, then use East Const. Why not? Be consistent is the more important part here. This rule was audited after many requests for guidance. And I found at least 3 issues on the guidelines GitHub repository with pages and pages of discussion about this topic. Some of the core guideline rules are neither rules nor guidelines. NL, the section is named Naming and Layout Suggestions. Those are not guidelines, those are not rules, that are suggestions. So when you have no other idea, maybe have a look here to get some inspiration. These rules are suggested defaults to follow unless you have reasons not to. So if you have reasons, just go ahead. Just don't mix like East cons, West cons all over the place. At least per library, per subdirectory or something like that, have a consistent notation. Also, Clang format can take care of this. Clang format can go ahead and make all your East const accidental East const to West const. I'm like my finger memory uses East const because I use it in private projects. At work we use West const mostly. And it happens once in 1,000 const ref, I write something const ref instead of const something ref. Clang format thankfully takes care of this. Formatting, this is really a tooling thing. We don't need guidelines about how to format our code. This is what .clang format is for, right? So please don't write in the guidelines. By the way, instead of tabs, we use 3 spaces for indentation. And the braces goes on the same line or on the next line or whatever. That's formatting. You don't want this in your guideline. You don't want to have to memorize all this kind of stuff, right? So please don't make me read formatting rules. Just provide the tooling to format code correctly. And whether you have a Git hook to format your code before checking in, or whether you have a CI rule that rejects your merge request when the code is not formatted correctly, that's up to you. That's a bit of project politics as well. But those kinds of things don't belong in guidelines because it's just unnecessary cognitive load for developers. So please do use Clang format or whatever to do consistent formatting. Another guideline. Use Singleton for objects that exist only once. Oh boy, did I have discussions about this one. Not at my current employer, I have to admit. This one is a previous one, but those were long discussions. So the intent of Singleton, I found actually a few pages of the original Gang of 4 book online as a PDF. The intent is ensure that a class has only one instance and provide a global point of access. And not, if a class has only one instance, use Singleton. Reason is, a global variable makes an object accessible, but doesn't keep you from instantiating multiple objects. So you might accidentally copy the global variable and stuff like that. That's the original reason from the early 90s in the Gang of 4 book. Use when there must be exactly one instance of a class and it must be accessible to clients from a well-known access point. So when everybody needs to basically access your logging and stuff like that, that's a reason to use Singleton. Not, oh, I have only one of these, make it a Singleton. What's the impact? Why did I have those discussions? Well, we had a 4.5-ish million lines of code base, and we had hundreds of singletons. Every single database table had a database table accessor singleton. Those were a couple of hundreds. And basically, when you touched a class and looked into its code, okay, this is tied to the singleton, this is tied to that singleton, and it's singletons all the way down. And every class, every unit test, you had to compile 1.5 million lines of code into this single unit test. 3,000 unit tests took 55 minutes to run. If you excluded the 2 long runners, then it was only 50 minutes to run. And at the end of it all was a 180 megabytes access database tied into the code base. Please don't. So interpretation matters. The interpretation of this particular design pattern has changed a bit. Even the gang of 4 authors have, like, I think in the early 2000s, have given an interview where they said, well, had we known how this design pattern has been interpreted over the years, we would not have written it, or at least not that way, because it's gone all wrong. So text has to be interpreted, interpretations change. We need to get a common understanding, what does this mean in these times, especially if, like, you have a design patterns from the early 19s. Does it still apply in 2020? Does it apply with modern C++? Do I actually have to use this? Because there are design patterns in that book, for example, that in modern C++ you just wouldn't use. You just use a std function. Modern interpretation of this one. If you need global state that you usually should avoid, then use a singleton. The alternative is dependency injection. Do we have singletons in modern C++ code? Yes, we do. std cout, std in. Probably any logging, you don't want to pass your logger down your dependency chain to every single class, but every single class wants to log something, or many classes want to log something. So in those cases, you just include the header that defines your global logging, whatever singleton, whatever framework you use, and that's okay, mostly. But please don't write hundreds of singletons yourself. Please don't use singletons for objects that exist only once, but be aware of when you actually want to use it. You might have seen, so this was added after the last time I did the talk, that after each please don't slide, I had a please do slide, not for this one. Guidelines for guidelines. So for your team. Understand the context and the rationale of the guidelines that you adopt. Why do you adopt those guidelines? When do they apply? When do they not apply? Why are they really important for your project? Projects are different, teams are different, so think about that. Guidelines can be broken, guidelines may be broken, so have an understanding of when and how to break those guidelines. Maybe write an explanatory comment. Yes, I know I've broken guideline, whatever, in here for that and that reason. Use naming conventions. You saw these application services, repositories, and stuff like that. If something is called a service, then I'm pretty sure I don't need copies, and then it's okay to have reference members. If something does not show like any of these symptoms, and it might be an actual value type, then I'm cautious when I see reference members, right? So naming can help you distinguish between areas where guidelines apply and where they don't apply. Concentrate on writing down guidelines that you can't automate, because cognitive load, if the tool just tells me you have violated a core guideline, whatever, then I don't need to write it down myself. And I also don't have to keep the guideline in my mind when I review other people's code, because I suppose they have run their static analysis and Clang Tidy already has gotten rid of all the stuff. Developers love automated tools. They tell us what to do. Well, do they really? Tools follow rules. Tools don't follow guidelines. Tool can say, well, yeah, this class looks like you actually want to follow this rule, or this class looks like, well, maybe you're managing some responsibility here, so it's okay to have your destructors, whatever. But most tools are not that sophisticated, so they will give you warnings where you say, I want to ignore this warning. I want to not have this warning in here. So we usually have to get rid of some guideline violation warnings, because it's okay to violate this guideline. Or sometimes it's the right thing to turn this warning off for one specific case. In other cases, fixing the code is the right thing. Sometimes, in some cases, you maybe just have to provide some additional parentheses or something like that to have the warning get away. And maybe it's a slight annoyance to write something more just to satisfy the checker, but usually it's a good thing to satisfy those tools. How to fix the code correctly is not always easy, so sometimes you have to think about it. Sometimes maybe you have to discuss with colleagues how to deal with specific cases. But we want to use the tooling and we want to be warning free, because if not, then we just start ignoring warnings. Then we just might as well not use the tool if we just ignore it. For example, C12, the reference thing, can be checked by clang tidy. And I want to say, well, this quote repository is a reference and that's okay. And then I can tell clang tidy, please don't lint here for any rule that ends with ref data members. I don't want to write the correct complete rule because it's CPP core guideline / no const or ref data members or something like that. It's ref data members, okay. I know what rule is meant here, right? And clang tidy shuts up, and it's okay. Guidelines means freedom, as we said before, and freedom means responsibility. So please don't turn off your brain. Not just, okay, guideline says this, I do this. It's a guideline, it's not a rule in most cases. Also, don't play the metrics. I've been on teams where we had things like Sonar or similar checkers that told us, well, this function is maybe a bit long. 60 lines, Okay, how do I get this away? My function calls function part 1 and function part 2, and they're all 30 lines. Okay, done. That's not how it goes, right? Find the correct way to address warnings. So in a long function, maybe there are smaller parts that you have to factor out and things like that. How about in code reviews? There will be places when you review code where guidelines are violated. It might be an honest mistake. Nobody is perfect. People get tired. They don't see that they violate a guideline. Maybe they don't know the guideline. Maybe it's on purpose and it's correctly done so. Or it may not be on purpose and you might have a point of discussion there. Find the correct way. Don't just say you violated the guideline, make it correct. Right? Tell them, okay, I've seen this and I think this violates guideline 24/7. What do you think about this? Oh, I didn't see that. Okay, I'll fix it. Or, no, it's okay. Guideline 24/7 doesn't apply here. So maybe add a comment that it doesn't apply here. So the next one who reads this doesn't try to fix it. Or have a longer discussion whether it actually applies or not. Guideline documents should be short and accessible. If you give me at the start of a project a 30-page Word document, well, there's a good chance that I will maybe skip most of it. There's a very good chance that I won't remember it. So what's the use of those kinds of documents? Especially if it's hidden somewhere in SharePoint and I didn't immediately put down the link to whatever that is, I won't remember how to find it because have you tried finding anything in SharePoint? I didn't. If you say, okay, this guideline is important for us, this is core guideline 28 or something like that, then provide a link. Then everybody can see the guideline, can see how it evolves, maybe it doesn't apply anymore, and can read the text. Don't write down just the title because, well, documentation is hard and we don't want to repeat like the whole page, right? And if you write down, don't use references, then the context will be lost and people will have a hard time arguing about it. What guidelines you want to use will depend on your team's situation, on your experience, on your knowledge. if you have an experienced team and everybody knows rule of 0, rule of 5, well, there's no use writing it down in a guideline document, right? It depends on the software landscape around it. So there are specific guidelines how to deal with specific situations that just apply to your project, because you're using some weird library that some third-party vendor provided to you and nobody else is using this library, but maybe you have some guidelines how to deal with specific cases with those. Those are good writing down because they will be nowhere else, right? So do we need the rule of 0 and 5 in the guideline document? Does your team know it? Have you agreed on exceptions? Guideline documents should be a living document. You should update it. Talk about the content of the document, more or less regularly. Reevaluate from time to time regularly whether all the guidelines still are relevant, whether they still apply, or whether you can just toss them out because, well, everybody knows the rule of 0 or 5 by heart by now, so maybe we don't need it anymore. Consider archiving this, maybe version control, something like that for new joiners so they can read, okay, this is stuff that we agreed on in the years past, so this is maybe something that I have to remember. But still, it should be a living document and it should stay short. For example, in our project, we have a weekly developer sync meeting where somebody might come up and say, well, I've noticed that our unit test cases are extremely long. They test like 5 different things and stuff like that, and maybe we should deal with certain situations differently. Then we discuss it and we come up with a guideline that we append to our guideline document and say, okay, in the unit tests, please refer to this and that. Because then in code reviews, we can say, well, we recently added guideline 25 about unit tests, and maybe you weren't there in the meeting or something like that, or you forgot, but this is our new guideline, and please change your unit test in this case. So you basically have documented what you agreed on. What about customers' guidelines? So who here is in the contractor / consultant business? A few hands, okay. The customer is always right. In the matter of taste, that's the whole proverb. So the customer hired you for doing their programming jobs. You are the experts. You can challenge customers' guidelines. Not always successfully. If you come with a team of 3 people into an organization of 20,000 and they have these guidelines for 10 years for all of the developers, then probably you have a hard standing. But you might say, okay, maybe this does not apply to our part of the code base or something like that, but guidelines can be challenged. So I've seen guidelines that were applied to all the code base where at some point we figured out this vocabulary sounds strange for C++. Oh, those aren't C++ guidelines. 95% of our code base is C#. Okay, maybe we should talk about what we do in C++ here. So, as I said in the beginning, these guidelines for guidelines were opinionated. So it depends on what your team is, on what your situation is, whether this applies to you or not. And those were guidelines for guidelines. Those were not rules for guidelines, yeah, right? So are there questions, comments? Thank you. A few.
Arne, thank you very much for your great talk. I loved the photos. The
Thanks.
Irish Tourist Board will be in touch shortly. So we have a question from Jan Babst, who asks, thanks for pointing out the origins of single return and mentioning that it has been dropped from MISRA C++ 2023 for the reasons you mentioned.
Thank you to Andreas for mentioning it to me that it has been dropped today at breakfast.
Yeah. Oh yeah, that's it. Yeah. So that's all we have today.
Thanks.
What do you think about retrospectively applying new guidelines to existing in production code? How would you go about that?
This is something that applies to my current situation a lot. Currently, the team I'm in is working on a estimated 20 to 30 million line of code base. And, well, we are not, so the part of the code base we are working in is more like in a few 100,000 lines, so not that big, right? But coming up with a new guideline and saying, okay, now we want to apply this to everything, please hold production for the next 6 months or something like that, it's not feasible, right? So there is the notion of the campground, Boy Scout rule, clean up where you work. And if it works and you don't have to touch the code, why apply new guidelines to it? So if you're working on a piece of code and it's violating kinds of your rules or guidelines that you have, then of course on the side, besides fixing the small bug or adding the 2 lines of new functionality, you can look around and fix some of the guidelines. So this is, I would count this as part of normal code maintenance. But don't just go on a spree and take a week to apply the new guideline everywhere. This is just a bunch of changes that will trip up people that look at the code. Why has it changed? It actually hasn't really changed. So it depends. With tooling, it's difficult, yes. In that same code base, we actually last week did Clang format everything. And I think there were about 20, 25 different pull requests for classes starting with A, with B, with C, about 20,000 files, because Bitbucket can't handle pull requests with more than 2,000 files, I think. So it's a difficult situation. In those cases, we said, okay, gradually when we touch files, so before that big bang last week, we said when we touch a file, then we Clang format at least the area of code that we are in, be it one function, or if it's a smaller code base, a smaller file, maybe the whole file. But you also don't want to go into a legacy 2,000 line of code file and apply 2,000 lines of diff just to fix 1 line of code, right? So it's a bit of a judgment thing to see what is reasonable, what can people deal with. Think about the impact that your change has on people reviewing your code in that moment and later when they skip through the history of the files. Does it answer the question? More or less. So the answer is it depends.
Okay, thank you for the excellent talk. Just a comment on the suppression of linter warnings.
Yes.
I tend to write the whole statement for Clang Tidy because it's also a way of communicating to a new developer which exact rule we like to suppress here.
Mm-hmm.
And sometimes it's even that we suppress 2 rules in a line and then we make it explicit what we write there. So it's just from our experience here.
Okay. Yeah. Especially there are some rules that are duplicated in Clang Tidy and you get the same, basically the same thing does violate 2 different rules because it's, yeah.
Hey, excellent talk. Thank you. I really
Thank you.
Good advice all around. So I'm a member of the Misra C++ working group, and I just want to emphasize one point that you made, right? Because you sometimes hear this excuse, we just have to use Misra, right? There's nothing we can do about the guidelines. So especially if you're in a regulated environment where you have to follow the guidelines, the things that you mentioned, that you have to understand the context,
Yes.
you have to understand the rationale, that's an obligation,
Yes.
right? It's even more important there. And instead of blindly following the guidelines, if you think that that's what you're supposed to do, go to the Misra homepage. There's a document there, Misra Compliance, which is available free of charge, that describes the intention, how these guidelines want to be applied, and what the framework looks like in which you can take this context into account. So yeah, absolutely what you said, 100% right.
Thank you. And I think even then, correct me if I'm wrong, you can pick subsets of Mishra, right? So you can define which of these rules actually apply and not say, okay, I have like whatever 5,000 rules that apply to my project, or 200 apply to my project. I have to check them all. It's a bit of work upfront, but yes.
We have another question from the online people. Arne Vogel asks, if we should be able to remember the reason for every guideline, isn't it a contradiction to say that tool-fixable things don't need to be documented?
So if you don't have to remember the rationale for guidelines that are tool-fixable. That was one of the points I tried to make, that if a tool can point you to the guideline, and if a tool can fix it for you, that should not be one of your project internal guidelines, that because a tool can fix it for you, you don't have to remember it. If you want to say, okay, the tool told me I shouldn't use reference members here, but I get the warning here, and I'm surprised about the warning because my code to me sounds reasonable, then maybe you have to follow the tool and say, okay, what does CPP Core Guideline, I don't know the number anymore, what does the CPP Core Guideline actually say? And it says, okay, this is only for copyable types, my service is not copyable, so it does not apply here. And in those cases, you have to look it up, and maybe you have to also write not only the no lint there, but a short thing, this is just a service, it isn't copyable, I don't, reference members are okay here, and then the no lint to provide the rationale why you violated the guideline. More comments? Yes?
You talked about getting new guidelines. Could you give us a guideline for discussing guidelines on the teams, especially when you're scattered across 3-4 locations, so it's hard to meet in place, you have to do it online?
So again, I from this current project I mentioned, we do have these weekly meetings, and those are online meetings. And usually when someone comes up with, maybe we should adopt this guideline, they write it down in the meeting notes beforehand, and they do maybe a bit of preparation, and then they show, okay, I've seen this core guideline, and it sounds reasonable to me that we should apply it to our project. They prevent the guideline, they prevent the rationale. So we have a basis of discussion. And then we discuss in the team, should we apply this? Does this really apply? It also depends on the team, right? We have heard it on the keynote by Titus, whether you just agree as a team or whether just one person says, okay, I now declare this guideline has to be followed. That's a bit up to the team structure of the team politics. But there are ways to get agreements on things like that.
Okay, I have a question rather about opinion of yours. Well, do not use exceptions. We kind of have this guideline within our thing, but we have a footnote in it. Use not exceptions over software packages boundaries. Don't use exceptions over architectural boundaries because they have great coupling,
Yes.
and you have to have detailed knowledge, and all the other components which rely on this also have to rely on these exceptions, etc. So we have this. Don't use exceptions over boundaries. What's your opinion on this one?
The one I was going on about was a few lines before, a few more lines before. This one. Explicit, everywhere, don't use exceptions, ever. Unless you reason, Google, and there says, unless there are good reasons against them. So, architecture boundaries are good reasons to maybe decouple your boundaries, either catch exceptions and throw new ones that are internal to your library, or just say, when I have an API for my library, this API doesn't communicate via exceptions, it does communicate via std expected via error return codes, whatever. So, but that does not mean that inside your architectural boundaries you cannot use exceptions, right? So this still applies. In general, use exceptions, except maybe not across those boundaries because, as you said, this creates tight coupling and stuff like that. So I would not put that as a footnote in an asterisk. I would put this as the rule: do not use exceptions across architectural boundaries. That's a perfect guideline. But it's a bit different to don't ever use exceptions, right?
Okay, I think we'll wrap it up here. Thanks very much, Arne.
Thank you very much.
Great talk.